All right, now that we've talked about exponent rules and scientific notation, we're ready to move on to how to simplify radicals and how that translates to rational exponents as well. So radicals can be rewritten as exponents. I'm going to show you that today. And really, we've done square roots, cube roots before, but they've always been values where they're numbers, or they've been numerical. But today we're going to talk about what happens if you have a variable and how we could simplify those things. So radicals and rational exponents is your title for today, and we're going to extend the concept of square roots to other types of roots. So I think we've talked about cube roots before, but in case we haven't, 2 is a cube root of 8 because 2 cubed is equal to 8. 2 times 2 times 2 is 8. Whereas 3 would be a fourth root of 81 because 3 to the fourth power equals 81. 3 times 3 times 3 times 3 is 81. So really, exponents and roots are opposites. Sometimes students will think that roots are division of some sort, which kind of makes sense because exponents are repeated multiplication, but really a square root and squaring are opposites. Any exponent and its corresponding root are opposites, not exponents and division. So here, just so that we are clear about our vocabulary, the index or the root, those are kind of interchangeable terms, or whatever you're taking your root by. So a fourth root, there'd be a 4 here. A cube root, there'd be a 3 here. If it's a square root, since that's the most common, they can write a 2, but often they'll leave it blank. The number underneath the root symbol we call the radicand, and then the whole thing combined we call a radical. So when we say radical, we're talking about the full expression, and if we say radicand, we're only talking about whatever's underneath. The index or root is just the number in front of our root symbol. Okay, so make sure you pause and get this part written down. Okay. Remember, if no index is shown, the root is 2, so that'd be a square root. Since they're the most common, most people don't bother to write them, but you are welcome to. So 4 squared is the same as 4 times 4, which would give us 16. So the opposite, the square root of 16, would be 4. These are opposites. So then 3 to the third power, or 3 cubed, would be 27. 3 times 3 times 3 is 27. So the opposite would be taking a cube root. The cube root of 27 is 3. Okay. So kind of moving on, we can also write radicals as exponents. And how that would look is whatever your root is really a fraction. So if I had, let's actually go back. I could rewrite this as 16 to the 1/2 power because it's a square root. Or this one I could have rewritten as 27 to the 1/3 power because it's a cube root. So if you have a calculator that doesn't have a root symbol and only exponents, or you just prefer one way over the other, you think one's easier to type in, whatever the case may be, this is another way you can get to the same answer. Or another way to just write them. So here what it's saying is the n, or the denominator of your fraction, is whatever root it is, and then if there is a numerator other than 1, that's what power you're taking it to, or the exponent that you would take it to after the fact. So 16 to the 3/4 power means I'm taking a fourth root of 16, and then I'm going to cube that. And really, you could do it in the other order where you do 16 cubed and then take a fourth root. Order doesn't really matter, but this order is the easiest to work with because you're going to get a smaller number in the beginning. Whereas if I cube 16, that's going to be huge that I'm going to have to work with. It'll still get to the same answer, but taking your root usually is easier first. So the fourth root of 16 is actually 2. Let me go ahead and pull up a calculator. I'll show you how to type that in. So to type in a fourth root, above, this is our exponent button. This little caret key is how you get an exponent. So if you prefer to type it in just 16 to the 3/4, you could do it that way. But to get a root, since it's just good to know, is the green right above that with the little x in front of our radical symbol. So we want to type in our 4 first for our fourth root, and then second, and then this key. And it should shrink up. If it doesn't shrink up, then you probably hit this key, which would be 4 times the square root, but we want the one where it'd be a fourth root. So there is a difference. And then we can type in 16. That'll give us 2. So then at this point, we would have 2 cubed, which is 8. Okay, and if you weren't sure off the top of your head, it's easier when they're smaller, but as they get bigger, it's harder. This again is your exponent key, so I did 2. This is our little caret key, 3. That'll give us 8. Or I think it's still important that you know what this means in the operation, but you can also type in 16 to the 3/4 to get 8. Okay, so let's keep going. 1 to the 2/5 is 1 is always so easy because 1 to any power, even a fractional power, is 1. Okay, if I take the 5th root of 1, that's 1. If I take 1 squared, that's still 1. Okay, 27 to the 4/3 means I'm going to take the cube root of 27, and then I'm going to take that to the 4th power. So the cube root of 27 is pretty common. You'll probably start to learn it, but it is 3. And then 3 to the 4th power is 81. And those are ones that I've just kind of learned because I use them so much, but you, of course, can always use a calculator for those. Okay. Talking about, this one's missing a radical. Let me put one on here. Let's say that we want the 4th root of this. Okay, I could, if I wanted to, rewrite these as a to the 4/4 and b to the 20/4. But we can simplify those. 4/4 is 1, or just a. 20/4 is 5, so then we'd have b to the 5th. So you can rewrite them like this, or you can just remember that it's division. 4 divided by 4 is 1, 20 divided by 4 is 5. All right, this time we have to the 1/2 power, and it's a power to a power, so we want to distribute that. And we take a power to a power, we multiply our exponents. So half of 6 is 3, and half of 4 is 2. And then the square root of y squared, 2 divided by 2 is 1, so we have another 1y here. And then we can finish this out with our product rule. So y squared times y should give us y to the 3rd because you're adding 2 plus 1. Okay, last one for this slide. I'm going to distribute my 2. So x, this to the 1st power times 2 would be 2. 1/2 times 2 is just 1. And then the 5th root of x to the 5th, 5 divided by 5 is 1. And then we can finish this out with our quotient rule. When we divide powers, we subtract our exponents. 2 minus 1 is just 1. So my final answer would be xy. Highlight here our final answers. Moving on. Finding the nth roots. So sometimes they'll write them like this where it says n equals 3, a equals negative 27. So n is our root. That means this would be a cube root. A is our radicand. And it says negative 27. So when you have an odd root of a negative number, your solution is negative. So in this case, it'd be a negative 3. If you have an odd root of a positive number, your answer is positive. If you have an even root, like this would be a 4th root of 16. It can be positive or negative if you remember back to when we were doing square roots. So the 4th root of 16 is 2, but it could be positive or negative 2 because both, if I do 2 times 2 times 2 times 2, that's 16. But if I also do negative 2 times negative 2 times negative 2 times negative 2, that is also 16. So even roots have 2 solutions, odd roots have 1 solution. It is also not possible to get an answer if you have an even root if a is negative. So if I have, for example, the square root of negative 4, that's not possible because 2 times 2 is 4, not negative 4. And if I choose to go the negative route, negative 2 times negative 2 is still positive 4. So there's no 2 numbers I can multiply to get that negative for even roots. Here, we have the cube root of negative 27, which we actually did write up here is negative 3. Or you could write it as negative 27 to the 1/3 power. That's still going to be negative 3. Here we have a 4th root of 16 or 16 to the 1/4. Again, same way to write that problem. In fact, I don't think I need to do these because they're just the ones above. We've already talked about them. So you actually don't need this bottom row, but you can add it if it's helpful to you. Last slide for today. Recall that radical A indicated the positive square root of A. So when we were talking about square roots originally, if there was nothing in front of the radical, we just assumed it was the positive root. Where if so similarly, an nth root of A, whatever root it is, with an even index indicates the positive nth root of A. So if we're going back to what we were saying here, you can't take a square root of a negative of an even root, you can't have an odd root. So really we're just focusing on even roots again. But if there is nothing in front of our root, like square root of 4, if there's nothing in front, that would be 2. But if there's a negative in front, that means it wants negative 2. So it's not always asking for both. Sometimes they specify which one they want. Since this is a cube root, we are allowed to take it of a negative. The cube root of negative 8 would be negative 2. This is saying that it wants the cube root of 8, but then we're taking it times negative 1. Like really there's a negative 1 here in front of this cube root. So this is negative 1 times 2, which also happens to be negative 2, but that's not always the case. So be careful, there is a difference between how these two are written, and they mean different things. Here we have a 4th root of 16, and since there's nothing in front, we're going to assume it only wants the positive root. So the 4th root of 16 is 2. And this one wants a 4th root of negative 16, which we just talked about on the last slide is not possible. Okay, if you have an even root, you cannot, an even index, you cannot have a solution because there's nothing that will be multiplied together 4 times that ends up being negative. It'll always end up being positive. All right, today we have a worksheet, so let me know that you're finished.